Hello everyone, this is going to be our first of several lectures for Pre-Calc Chapter 5. This is 5.1 lesson. This is for the 23rd of March, and again we're going to be doing the lecture for 5.1. There will be homework assigned from the section. Actually going to divide 5.1 over 2 separate days, going to separate the video into 2 separate pieces. Your job is to watch the video. Listen very carefully, re-watch the video to the extent that you need to, and then work on the home assignment. You will find on My School app a discussion assignment for Chapter 5. If at any point while you're working on your home assignment you come up with questions, please enter your questions in the discussion assignment. I will be monitoring that and I'll reply to you. Also, our mandate at this point is that you will have daily assignments completed by 9 p.m. Look for an assignment on My School app. You're going to upload your written work, your written homework as a PDF to that assignment. Now I know for this course we don't normally collect homework per se, but for the duration of the distance learning period, that is how we will be operating. So I will be looking for those assignments to be uploaded to me on a daily basis by 9 p.m. If I find that that's not happening, then I'm going to be reaching out and trying to figure out what's going on. So 5.1, let's get ready, let's go. If you are at home without your textbook, you may find the pages for the sections that we're covering on My School app. They are inside of the discussion assignment. Please find them, but do get a means, if you would, to get to school and retrieve your belongings if you have not done so already. Okay, so here we go, trig identity, section 5.1. Sophomores and juniors, this is going to be a bit of a reprise. We had already launched into this section as well as the following section shortly before spring break. Seniors, this is your first blush at this. But again, we had done a lot of this in chapter 4, so we're now going to start to apply the trig identities. I'm going to work through the checkpoint problems for us, just so that we have additional solved problems to take a look at. The examples, Mr. Larson does a beautiful job with those, step-by-step instructions. So again, I'm going to be pushing through the checkpoints for 5.1 that are associated. We're going to get up through 7 in this video. That's going to help you to do then the first set of homework problems, which you're going to be due this evening, the 23rd by 9 p.m. Numbers 7 through 48 on page 48. Now you know that you have access to the full solutions. You know that they're again on the My School app page for this course. They're in the download section. So as you're working, feel free to check your work. But again, if you run into questions, also please go ahead and deposit your questions in the assignment, the discussion assignment for this chapter. Okay, so taking a look at the checkpoint for example 1, this is us just using our trig definitions, our identities. This one had to do with a tan example. So example 1 checkpoint, tan of x is 1/3, and cosine is negative. Now we know for a fact that tan is going to be positive and cosine is going to be negative in quad 3. So drawing our initial triangle for the setup in this case, we have opposite over adjacent. So we know in fact that we have really a -1 and a -3 here. That ratio then turns positive. Using Pythagorean theorem, then we would know that the hypotenuse, of course, is the square root of 10. The directions for the problem then say, okay, given this scenario, please then define the other trig values. So sine of x, of course, is opposite over hypotenuse. This is going to be -1 over root 10. Rationalizing the denominator, this is going to be root 10 over 10, of course, in the negative. Cosine, adjacent over hypotenuse. This is going to be -3 over the square root of 10. Again, -3 root 10 over 10. Tan has been provided in the given information, so moving on. We then have the reciprocals. We have cosec, which is going to be hypotenuse over opposite, so that's going to be then negative square root of 10. We also have secant, which is hypotenuse over adjacent. This then is square root of 10 over -3. And then we have cotan, which is going to be adjacent over opposite, -3 over -1, and the ratio, of course, turning positive. So again, use the cues and the clues that we've talked about so far this semester with respect to the trig identities, looking for location, location, location. These two together put me into quad 3, build the triangle, still build the triangle, and utilize the definitions. This is checkpoint for example number 1. Moving on to example number 2, simplifying the trigonometric expression. Again, we did a lot of this in chapter 4. We're going to continue with this in chapter 5. You will notice on page 350 of the textbook, all of the identities have been assembled in one place. They were sprinkled throughout chapter 4, but they've all been assembled for your viewing pleasure on page 350. Put this on a card. We talked about this. Put this on a note card. I've teased with you before, but I'm kind of serious. Put it under the pillow at night. It has to be absorbed. You have to know these, the cofunctions, the odd and even identities, the Pythagorean identities, the quotient identities, as well as the reciprocals. You just never know which ones you're going to need for the given problem. So let's take a look at a simplifying checkpoint for example number 2. We have an expression, it's not an equation, so all we're charged to do here is to simplify. We have cosine squared x, and we have cosec, and we're subtracting cosec. You will notice here that we have a common factor. We have a binomial with multiple trig values, but we do have a GCF called cosecant of x. So we're going to go ahead and factor that out, leaving us cosine squared x minus 1. Well, again, the Pythagorean identity indicates that this is going to be the equivalent of negative sine squared x. So now we have cosec x times negative sine squared x. Well, cosec is going to simply be 1 over sine x, and why is that important to use that reciprocal identity? Because then if I'm in terms of only sine, I have the opportunity to simplify here. So final answer, negative sine x. Again, our goal here is to minimize the number of independent terms and to minimize the variety of trigonometric function values. So in this case, we were able to GCF factor, we were able to employ a Pythagorean identity, we were able to employ a reciprocal identity, and we were able to simplify by canceling common factors between the fractional factors. Checkpoint number 2. Checkpoint number 3, let's move on. Specifically factoring, we did a little bit of GCF factoring in checkpoint 2. Let's take a look at checkpoint 3, more factoring. Using this then to our advantage. Checkpoint number 3 says, specifically factor. Didn't say simplify, it just said to factor. So now we have secant squared theta minus 1. Well, isn't it true that the first term is a perfect square of secant? Isn't it true that the second term is a perfect square of 1? And this is a difference. So this is a difference of squares. So from algebra, we remember the pattern. Square root of the first plus square root of the second times square root of the first minus square root of the second. That's all that we're obligated to do. This is a linear factorization. In other words, we've gone from a quadratic scenario to a secant to the first power, if you will. We are fully factored. That is letter A. Letter B is a little different. This time we have 4 tan squared theta plus tan theta minus 3. This is a trinomial. 3 terms. Good news is we're only in tan. We are 2, 1, and none with regards to degree. This is going to turn into a trial and error trinomial. So trial and error. So again, knowing that we've got a middle term that's positive and a third term that's negative, that's going to guarantee to us that we have a minus and a plus here. Factors of 3, a only 1 and 3. Factors of 4 could be 4 and 1 or 2 and 2, but remember we're building that OI, that O plus I in the FOIL to a positive 1. So when it's all said and done, this one's going to be 4 tan theta minus 3 and tan theta plus 1. Please FOIL and you can check your work. Again, this is a linear factor. This is a linear factor. We have factored completely. Continuing on with our factoring, take a look at example number 4. Another trinomial scenario, however, a little bit more complicated because in checkpoint number 4, you'll notice we are in secant squared, this time now plus 3 tan x. So again, it's a trial and error trinomial scenario with a quadratic. However, this time we're dealing with both a secant function and a tan function within the same expression. We can't factor immediately. We're going to have to do a substitution. Well, taking a look, the Pythagorean identity substitutions work specifically with the quadratics. That's an easier way to go than trying to create perhaps a quotient function with tan and then also creating a reciprocal function here. We don't want to generate fractions if we can help it. So let's work with the secant squared first. Replacing that then with 1 plus tan squared x. So again, this is a direct substitution to here, leaving this linear tan x alone, and of course the plus 1 on the end. Combining like terms and reorganizing our lives here, we have tan squared x plus 3 tan x plus 2, 1 and 1, the constants can be added. Again, now it's a trial and error trinomial. Lead coefficient is a 1, tan x plus 1, and tan x plus 2. 2 plus 1 makes 3. We have linear factorization, so we're complete. Checkpoint number 4. Moving on then, continuing to simplify. In checkpoint number 5, this once again, we're going to find that we have multiple trig values. We have a variety of trig values, and we're going to need to work within that framework before we actually simplify. So we have cosec in checkpoint 5. We have cosecant of x minus cosine of x and cotan of x. Again, 3 different trig function values to consider. Wouldn't it be nice if we could write them in fewer? Oftentimes, if all else fails, consider writing or rewriting in sine x and cosine x only. So let's revisit and see if we can accomplish that. Cosec is, of course, then 1 over sine x. Cosine x, we'll leave that guy alone for the moment. Cotan x, well, cotan x is cosine over sine. If I pull this together, I'll notice that I actually have a singular common denominator. This is now 1 minus cosine squared x all over sine x. Well, this is a good news story because the Pythagorean substitution would tell me that 1 minus cosine squared x is sine squared x, and sine squared x over sine x simply then is sine x. So again, starting with a variety of trigonometric values, using the identities for substitution purposes. This time I started with 3 different trig function values, so make the attempt perhaps, make this your plan. Rewrite in sine and cosine only, reciprocal, quotient, gather together over common denominator, Pythagorean substitution, and then canceling common factors. This is checkpoint number 5. Checkpoint number 6. Now we're going to start adding. We've got a binomial scenario which has a fraction. So I'm going to go ahead and move back over where we started to to make some space. So checkpoint number 6 says I've got two fractions and they have differing denominators. Interestingly though, they are in fact a conjugate pair. It's going to be helpful to us as we move on. For now, we're just going to think about this as an LCD. So we're going to find our LCD and our equivalent fractions, and we can take it from there. So we start with 1 over 1 plus sine theta plus 1 over 1 minus sine theta. So again, understanding that these are binomials. They are an individual quantity which must be considered. We can't separate these. So LCD here is simply 1 plus sine theta times 1 minus sine theta. So now we're going to create those equivalent fractions. This is an expression. The denominator will not disappear. We need to be reminded that we're going to be left with 1 plus sine theta and 1 minus sine theta in that denominator. This, of course, was lacking a 1 minus sine theta. This fraction lacking a 1 plus sine theta. So now let's go ahead and combine like terms. Well, the sine thetas are going to cancel. That's a good news story. That's going to just simply leave us with a 2 over 1 minus sine squared theta. For these are the factors of the difference of squares. Well, 1 minus sine squared theta is simply, by Pythagorean substitution, cosine squared theta. So, final answer, 2 over cosine squared theta. Again, we've met the goal. We had multiple terms. We were able to combine them. We have an answer which is strictly in terms of a singular trigonometric value. So again, using LCD, equivalent fractions, Pythagorean substitution, and simplify at the end. Checkpoint number 7 is going to follow using similar logic. In checkpoint number 7, it says to rewrite so that we are not in fractional form. Sometimes this is important. It says 1 over 1 plus sine x. 1 over sine x is the example 7. We're going to do the checkpoint. Cosine squared over 1 minus sine theta. Now we talked about over here in 6 that we have this idea of a conjugate pair. Well, we're going to use that to our advantage here. Other than the number 0, any number divided by itself equals 1. So I'm going to be really particular about what I'm choosing here. I'm going to multiply this fraction by the number 1, but I'm going to express it as 1 plus sine theta and 1 plus sine theta. Again, this ratio still represents the number 1. I'm simply rewriting. But when I multiply, you'll notice again, I'm left with 1 minus sine squared theta. This is a good news story. This is going to then send me into the Pythagorean substitution. In the numerator, I'm actually just going to let this rest here for a minute. Knowing that 1 minus sine squared theta is in fact cosine squared theta, they in fact will cancel, leaving me with 1 plus sine theta. So, we've now gotten to the point where you are more than able to address numbers 7 through 48. We'll pick up with a second video which will finish this section. Again, please make sure that you upload your PDF to the assignment by 9 p.m. tonight, and we'll pick up with the second video for tomorrow. So, enjoy.